Alright, so we're going to continue our exploration of factoring, and we're going to look at factoring trinomials as a product of binomials. And so before I get into the factoring, I want to start off with two binomials multiplying each other, and we're going to see how it works out when you distribute those out and try to use that to figure out how these will factor. So we could have a situation like this, where you have x plus 3 times x plus 11, where both of our binomials are, all the terms are positive. And so, if I just wanted to multiply this out, I would do my normal distribution, distribute the x, the first x term in the first binomial to both parts of the second binomial, and then distribute the positive 3 term to both parts of the second binomial, and then combine like terms. 11x and 3x give us 14x. And so that one where all the terms are positive. Now we look at this product of binomials where the second term in each binomial is a negative. And again, distribute that all out like we normally would. Notice the two middle terms, negative 8x, negative 6x, those combine together to make negative 14x. Since they're both negative, we find the sum of those values. Here we go, x minus 4 times x plus 12. So one of our second terms is negative. Multiply this out. 12x, negative 4x. Notice those two middle terms have different signs. So we're going to figure out the difference between 12 and 4, 8. And we're going to take the sign of the larger term, so 8x. And then notice this last term is a negative 48. So on the previous two, we either had a positive constant times a positive constant. We got a positive 33. A negative constant times a negative constant. We also got a positive 48. Here we have a negative constant times a positive constant, and we get a negative 48. It's going to be important, those distinctions. So let's look at the fourth possibility is, again, one negative, one positive. Multiply this out. In this case, the negative 9x is larger than the positive 7x, so we're going to get, when we put those together again, we find the difference between 7 and 9, and we take the sign of the larger one, negative 2x. And again, we're ending our answer here with a negative. So what I want to do is I want to look at each one of these situations individually and see how these can show us how to factor. So let's look at this first problem, this x plus 3 times x plus 11. You notice I've color-coded some things here. Notice the x and the x in the two binomials, those made the x squared, made all the other little x's throughout the problem. And so as long as, if I look at that final trinomial, as long as I have an x squared, that's telling me I have an x and an x in those binomials. Now notice my 33 in my final answer is green. And at the beginning, I had a blue 3 and a yellow 11. Well, if you think about it, if you combine blue and yellow, you make green. So by multiplying 3 and 11, I made that 33. But notice the 14 in my final trinomial is also green. That's because that was formed by adding those two middle terms. And you look at the two middle terms, the 11x and the 3x, notice that 11 is exactly the same number as I had in the parenthesis at the beginning, and that 3 is the same number I had in the parenthesis there. And those added together, so they combined, again, yellow and blue made green. So the idea here is the 33 is formed by those two numbers multiplying each other, and the 14 was formed by those two numbers adding together. So one number is multiplying, one number is adding. So when I look at it, if I was looking at x squared plus 14x plus 33, if that's what I started with and I wanted to figure out what those parentheses were, I would ask myself the following question. What are the factors of 33 whose sum is 14? Where does the 33 come from? Well, it's the last term. So that number is formed by multiplication. Now the reason I want the sum is because it's a positive 33. In order for that to happen, that means both of my two numbers had to be the same sign. So when you multiplied 3 and 11 to get a positive 33, they both had to be either both positive or both negative. no matter what, as long as the signs are the same, you're going to find the sum of those two numbers. And then what should that sum come out to be? It should come out to be that 14 number. So that's the way I'm going to look at that expression, is I'm going to say, what are the numbers that multiply and make 33? But if I add them, I get 14. So let's look at this problem. X squared plus 8x plus 12. And what I'm going to ask myself is, what are the factors of 12 that add and give me 8? And so I'll think about, what are all the factors of 12? So 1 and 12, 2 and 6, 3 and 4. And I think about, what do I get if I add those numbers together, those pairs together? So 1 and 12, I add those, I get 13. Well, that's not 8, so that doesn't work. If I take the 3 and the 4, I add those together, that's 7. That doesn't work. If I add the 2 and the 6, I get 8. Now, it is possible you could run into problems where maybe they gave you a number, maybe it was x squared plus 5x plus 12, in which case it would not be factorable. There aren't any pairs of factors that could add and make 5. So watch out for that. We call those non-factorable. None of the problems here that I'm going to demonstrate are going to be non-factorable, but that can happen. So my two factors, what are the factors of 12 whose sum is 8, 2 and 6? So they're both the same sign, and they're both going to be positive, because that's going to make it a positive 8x. So this is going to be x plus 2 times x plus 6. What are the factors of 20 that add and give you 21? So again, you're looking at the last number, what multiplies and makes that, but if you add them, you make the middle one. And I go through the factors of 20. So 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. Well, if you add 2 and 10, you get 12, so that doesn't give me 21. You add 4 and 5, you get 9, that doesn't give me 21. But if you add 1 and 20, that gives you 21. So that's my pair of factors. And again, they have to be the same sign, that's why I'm adding. And they have to both be positive to give me a positive 21. So x plus 1 and x plus 20. So let's look at this one. Factor x squared plus 5x plus 6. So I would suggest you pause the video for a second, think about it, write down what you think the right answer is, and then start the video. So I'm going to give you, just pause the video and try it yourself. Okay, so if you pause the video, then what you should have asked yourself is, what are the factors of 6 that add and give you 5? And the factors of 6 that add and give you 5 are 2 and 3, not 1 and 6. Those subtracted make 5. So 2 and 3 add, they have to both be the same sign, and they have to both be positive. So x plus 2, x plus 3. All right, so let's look at this next problem, x minus 6 times x minus 8. And again, if we multiply that all out, we see that the 48, if I look at that last term, all the x squares come from the x. All the x's come from the x terms in both of my binomials. 48 is formed by multiplying negative 6 and negative 8 together. And negative 14 is formed by adding negative 8 plus negative 6. So you find the sum of those two. Since they're both the same sign, you find their sum. So this is very similar to the problems we just looked at. The only difference here, so the question would be the same. What are the factors of 48 whose sum is 14? The only difference here is when you find those factors, they're both going to be negative. That's the only difference. So I'm asking myself, what are the factors of 48? Because my last term is 48. Whose sum, the fact that that's a positive 48 means the signs are the same, so I'm going to add them together and gives me 14. And the only difference here is it's going to be a negative number plus a negative number. That's the only difference. So I look at this and I go, what are the factors of 14 that add and give me 9? And I go through the factors of 14. So 1 and 14, 2 and 7. 1 and 14, if you add those, you get 15. That's not the right combination. 2 and 7, you add those, you do get 9. So they're the same sign. That's why you can add them. And they're both, whatever that middle sign is, in this case, they're both negative. So x minus 2 and x minus 7. Let's look at this problem. What are the factors of 48 that add and give you 16? So I go through the factors of 48. And 48 has a few. 1 and 48, 2 and 24, and so on. So you're thinking about which pair has a sum of 16. So 1 and 48, that has a sum of 49. 2 and 24, that has a sum of 26. 3 and 16, that has a sum of 19. 6 and 8 have a sum of 14. So 4 and 12. So those are my two numbers, and they have to be the same sign. That's why I'm finding their sum, and they have to both be negative. So negative 4 and negative 12. So let's look at one more. X squared minus 10x plus 21. So notice again I have a plus at the end, and the middle term's negative, so that means the plus is telling me they're both the same. The middle term is telling me they're both negative. So what are the factors of 21 that add and give me 10? They're both negative. Those would be x minus 3 and x minus 7. 7 and 3 multiply and make 21. If you add them, you get 10. And since they're both the same and they're both negative, they have to both be x minus 3, x minus 7. All right, so let's look at this problem. This problem's a little different. Here, notice a lot of this stuff is the same as before, except if I look at that trinomial at the end, that 8x, notice the sign of the 8x is yellow. That's because if I look back in the problem, between the yellow 12 and the blue negative 4, the larger of those two was the 12, the yellow number. So I took the sign of who was bigger. So what I'm going to ask myself in this question is not what are the factors of 48 that add and give me 8, but what are the factors of 48 that subtract, or whose difference is 8. So again, I'm looking at, you're basically reading that trinomial in reverse. You're asking yourself, what are the factors of 48 whose difference is 8? And notice the sign of the 8 is the larger number. So whichever of the two numbers is larger, you're going to take that sign. So this tells, the fact that this is a positive 8x tells me the larger number is positive. So I'm looking at this x squared plus 9x minus 22. And I'm asking myself, what are the factors of 22 whose difference is 9? Not whose sum, whose difference is 9. And so I go through, okay, what are the factors of 22? Well, 1 and 22 and 2 and 11. And if we subtract those, find the difference. Well, 1 and 22 are different by 21. So that's not 9. But 2 and 11 are different by 9. And if I look at that 9 in my problem, it's a positive 9. So the larger of these two must be positive. So the 11 is positive, which means the 2 is negative. So x minus 2, x plus 11. So look at this. Let's factor x squared plus 5x minus 6. So I'm going to ask myself, what are the factors of 6 that are different by 5? And so the factors of 6, 1 and 6, 2 and 3. Well, 2 and 3 are different by 1. 1 and 6 are different by 5. And again, I notice that's a positive 5. So the larger of the 1 and the 6 has to be positive. So the 6 is positive, the 1 is negative. All right, let's look at this problem. Let's factor x squared plus 6x minus 16. So why don't you pause the video, give yourself a few minutes, try to figure this out, and then start the video again. All right, so what we should have asked ourselves is, what are the factors of 16 that are different by 6? And that answer would be 8 and 2. 8 and 2 multiply and make 16, but if you subtract them, you get 6. And the larger one has to be positive because that's a positive 6. So the 2 is a minus, the 8 is a positive. All right, so let's look at the fourth situation. And in this one, the larger number was a negative number. So again, we see we're still finding the difference, still negative 63. We're still, subtracting 7 and 9, but we're taking the sign of the negative one because the negative one was larger this time. So this is, again, just like the previous slide, but, your answers are, the larger answer is going to be the negative number. So, but you're going to ask yourself the same question. What are the factors of 63 whose difference is 2? The larger one is the negative one because that's a negative 2x. So I'm going to look at this and I'm going to ask myself, what are the factors of 24 that are different by 5? So I go through all the factors of 24. 1 and 24 are different by 23. 2 and 12 are different by 10. 4 and 6 are different by 2. 3 and 8, though, are different by 5. And because I want that to be a negative 5, the larger one, the 8, has to be the negative. So positive 3, negative 8. So look at this one, x squared minus 11x minus 26. So what are the factors of 26 that are different by 11? And again, factors of 26, 1 and 26, 2 and 13, and that's it. 1 and 26 are different by 25, so no, but 2 and 13 are different by 11. It's a negative 11, so the larger number has to be the negative 1, so the 13 is a negative. So x plus 2, x minus 13. All right, and then x squared minus 6x minus 55. So we ask ourselves, what are the factors of 55 that are different by 6? The larger of those is the negative 1. So different signs, larger one's negative. And 5 and 11 are different by 6, and the 11 has to be the negative 1. So negative 11, positive 5. All right, so why don't you try each of these 4 problems, pause the video, and give it a shot. Okay, so what I'm going to ask myself on the first problem is, what are the factors of 24 that are different by 10? And the answer to that is 2 and 12. 2 and 12 are different by 10. If you multiply them, you get 24. And the larger one is negative. So the 12 is negative, the 2 is positive. So x minus 12, x plus 2. And notice, it doesn't matter which parenthesis you write first. If you want to write the x plus 2 parenthesis first and the x minus 12 parenthesis second, that's the exact same answer. What does matter is the correct sign goes with the correct number. So it doesn't matter which parenthesis comes first, but it does matter, that the correct sign is with the correct number. All right, let's look at the second one. What are the factors of 24 that add and make 10? And that would be 4 and 6. 4 and 6 multiply and make 24, but if you add them, you get 10. And we're adding them because of the same sign, and the middle sign tells me they're both positive. So positive 4 and positive 6. X squared plus 10x minus 24. Again, what are the factors of 24 that are different by 10? 2 and 12. But this time, the larger one is positive in order to make that positive 10x. So x plus 12, x minus 2. And then this last one, x squared minus 10x plus 24. Again, I want to find the sum of the factors of 24 that add and make 10. So again, 4 and 6. But this time, both of them are negative. So that plus 24 tells me the signs are the same. So I'm going to add them. I'm going to find their sum. But they're going to give me a negative. So they have to both be negatives. Let's look at some special kind of factoring here. A little bit more advanced stuff. So you look at this and you see y to the 4th and you think, whoa, this is different. But it's not really. This is exactly the same problem types that we've been looking at. Notice that y squared in the middle, and then you have y to the 4th at the beginning. What that tells me is in my 2 binomials, instead of starting with x and x, or y and y in this case, we're going to start with y squared and y squared. So just like before, where that I had those red x's and they made the x squared and the x. Well, these are going to give me y squareds, and those are going to make the y to the 4th and the y squareds. So what I'm really going to look at here is, what are the factors of 12 whose sum is 8? And the factors of 12 whose sum is 8 is 6 and 2. So this is just going to be, and they're both the same sign. That's why I'm finding their sum. And they're both positive. That's positive 8. So y squared plus 2 and y squared plus 6. So it's exactly the same factoring as if that had been like x squared plus 8x plus 12. The only difference is, instead of saying x and x, you're saying y squared and y squared. That's the only difference. Now compare that to this problem. In this problem, notice you have that 2x squared y and minus 6xy minus 20y. 2, 6, and 20 are all even numbers, which means 2 goes into them. And then all of these all have a y. So again, the first thing you always want to look for when you factor, and I haven't done that up to this point because we weren't talking about factoring in general, but the first thing you always look for is a GCF, a greatest common factor. And all of these have a 2y in common. So if we factor that 2y out and divide each term by 2y, we're going to get x squared minus 3x minus 10. And so now I can look at this inside part and I'm thinking, oh, I have a trinomial here, it's probably going to factor as a product of binomials. So x and x, and then those back parts. And what are those back parts going to be? Well, the factors of 10 that are different by 3, and that would be 5 and 2. And they have to have different signs, that's why I got a negative 10. And the larger one has to be negative, that's why you got a negative 3. So x minus 5 and x plus 2. Don't forget that 2y, though, that's sitting out front. That is also a factor of this problem. Alright, let's look at this problem. Well, one of the big issues here is this problem is in the wrong order. So we should put it in the correct order. X squared, then x, then constant. Then we run into this problem where the x squared term is negative, and that's just going to make life much more complicated than it needs to be. What I want that to be is a positive x squared so that I can factor this just like all these other examples. So what I'm going to do is I'm going to factor out a negative, or in other words, a negative 1. And what that's going to do is it's going to change all the signs. So that x squared is now as a positive, that 4x is now a positive, and that 12 is now a negative. And so when I look inside here, what I want to ask myself is, what are the factors of 12 whose difference is 4? So what are the numbers you multiply and make 12, but if you subtract them you get 4. And that would be 2 and 6. And again, I want this to be a positive 4, so the larger of the 2 and the 6 has to be the positive. So this is going to be x plus 6, x minus 2, but don't forget that negative out front. That is still part of the problem. And again, we're going to be eventually combining several factorings together. And we want everyone to be the same order if we can, the same x and then our constant for every single parenthesis when we do our factoring so that we can compare different values to each other. So that's factoring as the product of binomials. We will get into situations where what if there's a number in front of your x squared that isn't a GCF, and that's going to be the next type of factoring. We're going to come back and we're going to do product of binomials again, but in those more complicated